Let's talk for a minute about how objects are actually put together under the covers and how the dot actually works in Python. To do that, I want to focus on this holding class that we've been working on over a couple of lessons here. And I'm going to make an instance of that. So let's make a holding instance that has some data in there. Okay, so there's my holding object. You'll notice that on this object, there are different attributes like name, shares, price, and so forth. How those are actually stored under the covers is that every instance that you make is actually a layer on top of a Python dictionary. Turns out there's an attribute dict that you can access, and you will see those attributes in a dictionary. In fact, you can pull them out of the dictionary. Like you could say hdict shares, for instance, and you'll get 100. Turns out if you put something into that dictionary, like if I were to put Yao is 42 in there, all of a sudden the instance would grow a Yao attribute. So it turns out that the objects that you're making are this layer on top of dictionaries. What you're actually doing in the init function is populating the dictionary. Keep in mind that every instance that you make gets its own dictionary. So if I were to make another holding object with different data, something like that, it has its own dictionary that holds that data for that instance. Okay, so every instance gets a dictionary, and the dictionary is where the attributes live. Now, knowing that, you can actually understand what the dot operator in Python does. It turns out that when you access an attribute, like you say h.name, that is actually coming out of the dictionary, doing a dictionary lookup. Similarly, if you change a value, like you say h.shares is equal to 50 or something, that goes down and it modifies the dictionary. And then there's this third operation of deleting an attribute. Like if I were to delete the attribute Yao, all of a sudden it disappears out of the dictionary. There's a very direct kind of connection between the dot operator and the fact that instances are represented by a dictionary. You will note that the methods of an object are not found there. Like this h has a cost method and it has a sell method. You do not see that in the dictionary. Like you do not see cost and sell there. The reason for that is that those functions are actually part of the class that h comes from. So there's this holding class that exists. It turns out that the h actually keeps a record to the class that created it, and that class actually has its own dictionary object. Turns out if you go to the class, you can look at its dictionary. That is where you're going to see things like the cost method and the sell method. So it turns out that when you do something like h.cost, what's actually happening is Python is following the class definition for that. And then from there, it's pulling that out of the dictionary on the class. So it can find the cost method there. And what it's doing is passing in the h to that method. And you get the result. The whole thing kind of layered on top of dictionaries. Having said that, one of the concerns that comes up is just how would you have any control on this environment? If you're writing a larger program, one of the things that somebody might want to do is try to lock down the environment, maybe to prevent mistakes or to encapsulate details or things like that. And in Python, you provide you will notice that there's kind of a lack of features for this. Like there's no notion of private or protected or access control or anything. Objects are just sort of exposed. I mean, you can access attributes and delete things and modify things. So how do you go about locking some of this down? We're going to see some techniques for that in the next few sections, but one specific thing I want to note here is that there is a practice in Python of using naming conventions to indicate your intent as a programmer. So one naming convention that you will see is the use of a single or a double underscore on an attribute. Turns out that if you have a class, like let's say I had a class spam, and somebody were to store an attribute on there with a leading underscore like that, it's actually understood in the Python world that that is meant to be sort of private. Meaning that if somebody were to create like an object like that, that underscore value, that's not something that you're really supposed to be accessing. You can still do it. I mean, you can still access the attribute and change it, but it's actually known in Python that you're not really supposed to do that. That same convention is actually followed for everything else. For instance, if you had a function in your code, like underscore funct, like that in some program, the fact that that started with a single underscore is an indicator that's probably some kind of internal function. So this is one of the rules that you will see in code is the use of an underscore to indicate that something is kind of private, an internal implementation. This is something to think about to start. Everything is a dictionary. Everything is exposed. You can name things to indicate your intent, but what we're going to look at in the next few parts are a few additional things that you can do to try and lock down the environment.